Performance of standard vapor compression cycle. So, the work of compressions in kilojoules per kilogram. In English unit, this is BTU per pound. Ulitin ko ni. Or, ang nasabi ko nito, ulitin ako. SI. English, same lang yan. Basta ang unit nyo was consistent. Is the change in enthalpy passes 1 to 2. Figure 10A or H1 minus H2. This relation derives from steady flow energy equation. So yeah, H1 plus Q is equal to H2 plus W, which is in energy in to energy out, where changes in kinetic and potential energy are negligible. So pag sinabay dyan, so back to your telepunta natin sa kung paano sinasama yung kinetic energy sa potential energy. Okay? Because in the adiabatic compression, the heat transfer Q is zero. The work W equals H1 minus H2. Diba? So the difference in enthalpy is a negative quantity, indicating that the work is done on the system. And absolute, siyempre positive to. Pag absolute, ginawa mo absolute. Sinagay mo, work of compression. Take note, small letter means in per unit mass. The heat rejection in kilojoules per kilogram is the heat transfer from the refrigerant and process 2 to 3. From the refrigerant to be palabas. Mababa kasi yung sa outdoor. Diba? Ang heat transfer from higher temperature to higher energy to lower energy, which is H3 minus H2. This knowledge also comes from steady flow energy equation in which the kinetic energy, potential, and work terms drop out. Kasi wala namang work sa condensation. The value H3 minus H2 is negative, indicating that heat is transferred from the refrigerant. The value of heat rejection is used in sizing the condenser and calculating the required flow quantities of the cooling fluid. Okay. So, negative ang sagot, pero sa absolute value, this is now positive. Talagay mo, heat rejection is positive value, absolute value nito. Kasi nga, naglagay ka ng rejection. Okay? Pag naglagay ka ng heat rejection tapos negative, parang double na yung double na yung pagkasabi mo. Na-oppose. Process 1 to 2 is the isentropic. Okay, tapos na. Now, the refrigerating effect in kilojoules per kilogram is the heat transferred in process 4 to 1. 4 to 1. Correct. Or H1 minus H4. Kasi yung direction yung inaanan. Knowledge of the magnitude of the term is necessary because performing this process is the ultimate purpose of the system. Okay. Refrigerating effect means ang actual definition niya is per kilogram or per pound. That is the effect. Pag refrigerating capacity, that is now in kilowatt or tons of refrigeration or BTU per hour. Basta may rate na yun ng refrigerating capacity. Pag effect is per unit mass. So the coefficient of performance of standard vapor compression cycle is the refrigerating effect divided by the work of compression. So this is coefficient of performance is H1 minus H2 divided by H2 minus H1. Diba? Nabaliktad na. Kasi kailangan positive siya. Sometimes the volume flow rate is computed at the compressor inlet or state 1. Kasi may purpose to. The volume flow rate is a rough indication of the physical size of the compressor. So, paano po ma-size yung pipe? Diba? The greater the magnitude of the torque, the greater the displacement of the compressor in cubic meters per second must be. Size din ng compressor. Now, the power per kilowatt of refrigeration is the inverse of ayan, coefficient of performance, and an efficient refrigeration system has a low value of power per kilowatt of refrigeration but a high coefficient of performance. Okay? Ginagamit tong power per kilowatt of refrigeration sa mga chillers. Malalaking unit. Next, in the system, meron tayong for the improve the performance, meron tayong mga add-on. So ito, una, yung heat exchangers. Some refrigeration system use a liquid to suction heat exchanger which subcools the liquid. So, tingnan niyo yung figure. So, dito yung heat exchanger. So, ito na yung numbering mo. 1, 2, 3, 4, 5, 6. Okay. So, subcools from 3 to 4. Subcools the liquid from the condenser, 3 to 4. With suction vapor coming from evaporator. The arrangement is shown in figure 11A and the corresponding PS diagram is 11B. Saturated liquid at point 3 coming from condenser is cooled to point 4 by means of vapor at point 6. Ito yung magano sa kanya. It being heated to point 1. Ito mainit to. So ito ang initin niya. Diba? Heat exchange. The refrigerating effect is either H6 minus H5 or H1 minus H3. Sa enthalpy yan. Project mo. Yan. Figure 12 shows a cutaway view of a liquid to suction heat exchanger. So yan. Minsan may cover to. Sa may cover yan. Makita mo sa Google. So ito yung gas. Hindi. Isa dyan gas, isa dyan. Ito liquid. Ito yun. Ito yung 6 to 1, dito 6. Ito yan. 6 to 1. Yung malaki kasi yung, dito po, 3 to 4. Ito yung 6 to 1. Opposite. Malaki yung vapor. Maliit yung liquid. Now, let's go to actual. May example tayo na problem solving. Vapor compression cycle. So the actual vapor compression cycle suffers from inefficiencies compared with the standard cycle. There are also other changes from the standard cycle which may be intentional or unavoidable. Some comparisons can be done by superimposing the actual cycle on the pressure enthalpy diagram of the standard cycle as in figure 13. So ito, this is the actual vapor compression cycle compared with the standard cycle. Ito yung actual, yung green, then yung blue is yung ideal vapor compression cycle. Standard. So rated. Yeah. So dito sa actual cycle, may superheating ka na superheat na hindi effect ng heat exchanger. Pag sinabing superheating lang, pwedeng superheating ng walang subcooling or subcooling lang walang superheating. So wala kang heat exchanger na ilalagay dun sa diagram mo. Okay. Pwedeng wala. Pag binanggit, so ibig sabihin ito ng equation mo. Pag walang binanggit, that is separate. So, at point 1, so dito siya, actual niya is 2. So, hindi sa isentropic. Sa isentropic or isentropic. So, actual cycle, from 2 to 3, bumaba yung pressure kasi may pressure drop. Difference ito is a 3. Sa 3, pumasok sa temperature, subcool, tapos 3 to 4, ano pa rin siya, Kasi na halping. Throttling process pa rin. 4 to 1, nag-drop siya 4 to 1. Okay? Ang drop lagi, siyempre, nag-reduce yung pressure mo eh. Hindi ka pwedeng tumaas dyan. Kung mag 4 to 1, taas ka. That is yung pressure drop. Okay? So, yan. So, this is now the macro cycle. The essential difference, so mabanggitan ulit dito, the essential differences between the actual and the standard cycle appear in the pressure drop in the condenser and evaporator. In the subcooling of the liquid leaving the condenser and in the superheating of the vapor leaving the condenser. The standard cycle assumes no drop in pressure in the condenser and evaporator. Because of friction, however, the pressure of the refrigerant drops in actual cycle. So, heat transfer nyo, di ba? Kinukuha yung pressure doon sa heat exchanger. Doon nyo kukunin yung pressure drop kung hindi given. The result of this drop in pressure is that the compression process 1 to 2 requires more work than in the standard cycle. Di ba lumaki? Okay. So, subcooling of the liquid in the condenser is a normal occurrence and serves the desirable function of ensuring that 100% will enter the expansion device. Superheating of the vapors usually occur in the evaporator. It is recommended as a precaution against droplet of liquid being carried over into the condenser. Superheating, hindi pwedeng hindi gumamit ng heat exchanger o ito, dito, liquid to suction heat exchanger. Pwedeng separate, diba? The final difference in actual cycle is that compression is no longer asymptotic and there are inefficiencies due to friction and other losses. Pwedeng asymptotic, pwedeng hindi. Kasi meron siyang efficiency. Diba? Efficiency yung compressor. Ang binanggit na efficiency, so kung ano yung kapag wag binanggit, just assume asymptotic. So examples. So page number. So examples. Sample number 1. A reverse Carnot cycle is used for refrigeration and rejects 1000 kilowatt of heat at 340 Kelvin while receiving heat at 250 Kelvin. Determine A, the COP, B, the power required, and C, the refrigerating effect. So, sabi nga, pinsan, pwedeng refrigerating effect is dapat kilojoule per kilogram or pwede naman siya maging kilowatt. Depende sa kasi wala ka namang mas dito. Divide. Pero normal, ang standard difference talaga, the definition of effect is per unit mass. Kasi pag inanap dito is mid D, what is the refrigerating capacity sinambayan, ibig sabihin, pares na sagot mo. So hindi. Yung isa, per unit mass. Yung capacity, kilowatt. So, yeah. Even QR is 1000 kilowatt, TS is 340 Kelvin, TC is equal to 250 Kelvin. So, kasi mga reference natin, gulo rin. A, the COP, B, the power required, C, the refrigerating effect. Solution, draw the TS diagram. Kasi Carnot cycle tayo. So, ito na yung 1, 2, 3, 4. TS, high temperature. TC, cold temperature. Ang H pala, hot temperature. So, TS, 340 Kelvin. TC is 250 Kelvin. QR is 1000 kilowatt. Nasa absolute na tayo. Kaya tayong mag-convert pa sa absolute. A, COP is equal to TC over TH minus TC is equal to 250 over 340 minus 250 is 2.778. Letter B. Work is QR minus QA. is equal to QR minus QR TC over TS. Back to your thermodynamics. Diba, gamay na kayo nito. It's 1,000 times 1 minus 250 over 340 is 264.7 kilowatt. Then C, QA is equal to QR minus W is 1,000 minus 264.7 or 735.3 kilowatt. So itong pag-solve na to, required A. So A ito muna. B. So B, power required. Yan mo, kuha mo. C, QA minus K. So hindi mo na kailangan mag-summarize. Yung sabi ko mag-summarize, yung ito hindi ka gumamit ng KBC, sunod nyo, nauna itong QA, sunod yung ano. So baga, hindi sunod-sunod yung pagka-solve nyo. Hindi naka-pattern sa ABC. So pag hindi naka-pattern, mag-summarize kayo ng ABC. A, C, O, P, B. Kasi may ano kasing required na nauna yung uling tanong. Kaya pag hindi gumawa, sa solution mo, hindi dapat mauna yung lagyan mo ng sagot yung huling tanong. Okay? Nauna, baliktad. Kasi may mga purpose nga yan, mga technique. Yan. So, example number 2. A reverse Carnot cycle has a refrigerating coefficient, COP, coefficient of 4. What is the ratio T max divided by T minimum? B, if the work input is 6 kilowatt, what will be the maximum refrigerating effect in kilojoules per minute and tons? So COP is equal to 4, W is 6 kilowatt. Required A, the ratio T maximum over T minimum. B is maximum refrigerating effect kilojoule per minute and tons. Solution. So this diagram, ginamit ko yung dati. TS is the T maximum. TC is equal to minimum. So A, the ratio T maximum over T minimum. Given is the COP, which is equal to T minimum divided by T maximum minus T minimum. Then 1 over COP is T maximum minus T minimum over T minimum is equal to T maximum over T minimum minus 1. Therefore, T maximum over T minimum is 1 over COP plus 1 is 1 over 4 plus 1 or 1.25. So, ito yung answer mo. Okay? Manipulate mo muna. Minsan, kung ano mas madali, manipulate mo muna yung formula o isubstitute mo na yung value. Kasi depende. Baka manipulate mo yung formula, masyado lang mahaba. So, isubstitute mo na yung value para maiksi. Diba? Kung mas maiksi yung manipulate mo yung formula, saka may substitute yung value, pwede rin yun. Masaya yun. Letter B, maximum refrigerating effect in kilojoules per minute. So QA is equal to W times COP is equal to 6 times 4 is 24 kilowatt. Now, in kilojoules per minute, conversion factor is 60. So 24 times 60 is 1,440 kilojoules per minute. So this is now your answer. And in tons, QA is equal to 24 over 3.516. 3.516 is a conversion factor, 3.516 kilowatt per ton. Is equal to 6.828 tons of TR, tons of refrigeration. So, answer. So, meron kayong nakikita sa isang reviewer noon. Ano yata yun? Gumagamit pa rin ng tan eh. So, hindi yun equal sa tons na TON. Iba yun. Iba yun. TONNE. Iba yung value nun. So, search nyo lang kung ano yun. Sa Pilipinas lang yun. Yung gumawa lang ng reviewer na yun, ginamit niya TONNE. So, pag na-encounter nyo yun, wag nyo yung gagamitin. So, example number 3. An ammonia vapor compression vapor refrigeration cycle operates at an evaporator temperature of negative 16C and a condensing temperature of 32C. Determine the coefficient of performance. A, for an ideal saturation cycle. B. For wet compression with vapor leaving the compressor, saturated vapor leaving the compressor. C. If the vapor at suction to the compressor is superheated 6 degrees C. So, gagamit na kayo ng table. Given evaporator temperatures, negative 16 C. Condensing temperature is 32 C. Required COP of ideal saturation cycle. B. COP for wet compression with saturated vapor leaving the compressor. C. COP of the vapor if the vapor at suction to the compressor is superheated 60 degrees C. A. Ideal saturation cycle. Andyan ang figure. So, in the drawing nyo, yung PSPC is the pressure, hot and cold. Numbering is 1, 2, 3, 4, saturated. Yung 1 saka and 3. So, from ammonia, stable 9 and 10. Stable 9 and 10 of any reference. Stable 9 and 10 to ng sa reference natin dito. Check nyo rin. Check nyo doon sa book. At state 1, negative 16 C evaporator temperature. SO1 is 1424.4 kJ per kilogram. So SO1 is 5.56 kJ per kilogram Kelvin. At state 2, 32 C condensing temperature is SO2 is equal to SO1. So yung di pa marunong magbasa ng table, so hanapin nyo to. Negative 16 C evaporator temperature. Paano nakuha to? So matutunan kayo o magtanong na lang sa klase. Marunong na. Diba? At state 2, 32 C condensing temperature with S2 is equal to S1 kasi isotropic to. So, at state 2, 32 C condensing temperature. So, naulit. So, interpolation. So, saturated temperature mo, this is 100 C and 120 C. Sa 32 C condensing temperature, makita mo na sa table, gusto ko yata to, meron siyang headings na 32 C condensing temperature against 32 against dito sa saturated, meron siya. Then may column na 100 C, andyan sa 32 C temperature, tapos to naman saturation. So this is 100 C, 120 C. So makuha mo lang yung entropy equal. So at 32 C, condensing, ito pala yung condensing temperature. So interpolate mo yung 32. 100 C is itong lalabas, 1657.9, entropy is 5.5207. Yung kasi pag interpolate tayo yung iba, hindi pa marunong. Yung interpolate mo, isa lang ang isang side lang, andun yung, hindi yung both side. 120 C, yan. Interpolate mo siya, lalabas ito, 178.2 and 5.56521. So dito, papasok yung entropy mo na 5.56. So in between siya. Pag hindi siya in between niya, gawa, nabawa dito, mas mataas. Mas ang baba to sa 5.56. So gumawa ka pa ng 130. 130 ang gamitin. Itong dalawa. Okay. Wag yung 100C, tapos kumuha ka ng 200C. Eh, meron namang mga 120 sa loob. Wag yun. Yung malayo na ang agwat. Okay. Kasi yung klase mo, gumawa ng 100 to 200, gumawa ka rin. Sabihin, malapit, agwat lang. interval. Huwag yung masyadong malayo. Kasi hindi siya linear. Hindi siya linear straight line. Hindi. Kurbada yan. Parang ganyan. Kurbada. Parang ganito. Yan. Nag-straight line itong isa mong point. 100C nandiyan. 120C. So, nag-interpolate ka. Dyan na. So, dito nalabas sa loob. So, kumuha ka ng mas malapit. Ano yung may available. Okay? So, S2 is equal to S1, 5.56. Interpolate mo naman to between 100 and 120C. Or 5.56. Ano yung enthalpy, which is H2 is 1672.9 kilojoule per kilogram. So, at straight 3, 32C condensing temperature. So, sa saturation properties, H3 is equal to 332.6 kilojoule per kilogram. Ito, saturated liquid. At state 4, so equal yon. H4 is equal to H3 is equal to 332.6 kilojoule per kilogram. Uulitin nyo yan. Or H4 is equal to H3. Okay na yan. Pero huwag kang gagawa ng H3. Pagdating dito sa solution, wala kang valuing H4. Diba? Hindi mo nilagay yung H4. So mali ka na. Anong value mo ng H4? Ilagay mo H4 is equal to H3. Okay? So pinipresent mo nga yung solution mo. So COP is equal to H1 minus H4 over H2 minus H1 is equal to 1424.4 minus 332.6 over 1672.9 minus 1424.4 is 4.394. So yung significant figures with 4.4, okay, kasi 39 na to, di ba? Okay. So dito sa entropy, this is kung ano na sa table, yun ang ilagay nyo. Huwag nyo bawasan. Ha? Okay, itong naman, enthalpy, ganun din. Kadalasan, on decimal place, isang numero lang sa dito. Kasi apat na yun eh, apat. So 5 significant na siya. Dagdag ng isa. Ganun, technique lang yan. Para maging maiba ang sagot. So ito, ganun din. So weight compression. So ito yung weight compression mo. At 32C condensing, H2 is equal to 1.2. Saturated siya, di ba? This is saturated vapor. H2 is equal to H3, 1469 kg per kilogram. H2 is 4.9589. So ito naman ang saturated. Dito, ito ang saturated. So paggawin mo man dito, so hanapin mo yung H1. Dito, H2. Dito naman H1 at S1 is equal to H2. Diba? So at 1, negative 16C evaporating temperature. S1 is equal to S2 is equal to 4.9589 kilojoule per kilogram Kelvin. So, no need to interpolate. Gagawin mo lang dito yung value dun ng saturation properties mo. So, H of F1 is equal to 107.8 kilojoule per kilogram at negative 16C. So, S of F1 is 0.4393 kilojoule per kilogram Kelvin. S of FG1 is equal to 5.1201 kilojoule per kilogram. So, may nawala ako dito, no? So, 1316. Okay. Okay. S of FG1 is ito, 1316.5 kilojoule per kilogram. S of F1, 0.493. S of FG1 is 5.1201 kilojoule per kilogram Kelvin. So, the quality X of 1 is equal to S of 1 minus S of F1 over S of FG1 or 4.9589 minus 0.4394 over 5.1207 is 0.8826. Kaya ako laging nagalagay ng 4 significant or 4 decimal places. Ito, 4 decimal places yan. Kung significant, ito was 21.6 or 5 significant is 21.6.5. So, alam nyo naman yung pag-round up kung mali o tama. Kaya lang yung iba, sulat lang ng sulat. Kumbaga, natamad ng numero. So, engineer kayo, dapat alam niyo yung mga numero kung kailan kailangan damihan, kailan kailangan kuntihan lang ng numero. Eh, ngayon, kailangan din more exact. So, kailangan mahaba yung numero. Hindi man masyadong mahaba. Mga ganyan. So, H1 is equal to SF1 plus X1 at H of FD1. So, H2 is equal to 107.8 plus 0.8826 plus 1316.5. Is H1 is equal to 1269.7 kilojoule per kilogram. So, at state 3, 32 C condensing temperature. Ano yung 3? Ito. Saturated din. Liquid. So, H3 is equal to 332.6 and S3 is 1.2343. Bakit kinuha dito? Hindi ko kinuha yung entropy kasi equal lang naman yung enthalpy niya, di ba? So, dito, isentropic to. Yan. So, at state 4, negative 16, evaporator temperature, S of 4 is equal to S of 3. So, 1.2343. So, X of 4 is equal to S of 4 minus SF1. Ganun din kasi yung temperature niya, di ba? Negative 16. So, S of FD1. So, X4 is equal to 1.2343 minus 0.4393 over 5.1207 is equal to 0.1553. So, H of 4 is equal to S of F1 plus X of 4 S of FD1. So, H of 4 is equal to 107.8 plus 0.1553 times 1316.5. So, H of 4 is equal to 312.3 kilojoule per kilogram. So, yun. Hindi yung pag ano na, kasi wala tayong available pinakitang kanyang TS diagram. So COP is equal to H1 minus H4 D ito. Yan. Divided by network S2 minus H1 minus S3 minus H4. S2 minus H1 minus H3 minus H4. Yan. Network or net heat. Pwede rin siyang H2 minus S3 minus the quantity of H1 minus H4. Pwede rin yun. Para sa labas niya. So COP is equal to 1269.7 minus 312.3 over 1469 minus 1269.7 minus 332.6 minus 312.3 is 5.349. So mas mataas to. Kaya lang, siyempre, ito yung, mas mataas yung COP niya. Kaya lang, with compression. Now, with superheat, at stage 1, so T1 is equal to negative 16 plus C or negative 10C. Diba 6C yung superheat mo? Temperature mo condensed sa evaporating is negative 16, so plus 6. Saturation is siyempre negative 16C. Baka tayo naman ang record. So, saturation pressure P1 is 226.45 kilopascal from refrigerant table. Ano yung refrigerant natin dito pala? Ammonia. So, ammonia table. At state 4, negative 16C, evaporator temperature S4 is equal to S3. Mali. Okay, ito tayo. Yan. Basa ng basa. Interpolation. So, saturated pressure mo andon, 200 and 250 may available. So, negative 10C, eksakto, di ba? So, kaya isa lang interpolation mo. So, interpolation sa enthalpy and sa entropy. Interpolate mo yung value at 226.45 kilopascal. H1 is 1439 kilojoule per kilogram. S1 is 5.62. So, at state 2, 32 condensing temperature, S2 is equal to S1. So, at 32 condensing temperature, ito yung papasok na available. So S2 is equal to S1 is 5.62. Yan, malapit yan. Ito, in between siya. So S2 is equal to 1695.6 kilojoule per kilogram. So at 32, at state 3, 32 condensing temperature, H2 is equal to, again, 32.6 kilojoule per kilogram. Saturated pa rin. State 4, H4 is equal to H2. So COP is equal to H1 minus H4 over H2 minus H1 is equal to 1439 minus 332.6 over 1695.9 minus 1439 is 4.307. Which is mababa. Standard kasi kami superior ka. Lumaki yung work. So example number 4. So refrigerant 12 refrigeration system requires a load of 54 kilowatts at an evaporating pressure of 270 kilopascal and a condenser pressure of 1009 kilopascal. The refrigerant is subcooled 10 degrees before entering the expansion valve, and vapor is superheated 14 degrees before entering the compressor. A twin cylinder compressor with stroke equal to 1.25 times the bore is to be used at a speed of 27 revolutions per second. So hindi na kailangan i-discuss pa yung pagkuha niya na para volume. The volumetric efficiency is 84%. So determine A, the quantity of cooling water in the condenser or an 11-degree increase in temperature, the bore and stroke, and C, the compressor power. Given refrigerant 12, refrigerant 12 is QA is 54 kilowatts. Evaporator pressure to 70 kilopascal. Condenser pressure 1009 kilopascal. Condenser pressure is subcooled 10 degrees C. Superheat 14 degrees C. Stroke is 1.25 times the bore. Speed 27 revolutions per second. Volumetric efficiency is 0.84. Cooling water at 11 degrees increase in temperature. Required the quantity of cooling water in the condenser for at 11-degree increase of temperature. B, the bore and stroke, and C, compressor power. Solution, so ito yung diagram mo. Merong superheat and subcool. Pero walang liquid to suction heat exchanger. Okay? No need yun. R12, table A11 and 12 ng Stoker engines. The state 1, 270 kilopascal evaporator pressure. Superheat is 14C and subcooling is 10C. So for T sub 1, hanapin natin. So ang available na pressure is 261 and 308.6. Saturation is negative 5 and 0. So at 270 kilopascal, the saturation temperature is negative 4.05 C by interpolation. So the superheat, the T1 is T sub sat plus superheat is negative 4.05 plus 14 is 9.95 C. Sinabay ko yung 5 at 4.05, hindi 4.1, hindi 4.0. Tapos para maganda yung halos exact yung natin. Accurate yung solution natin. So, and P1 is 270 kilopascal. So again, sa superheated properties ng R12, meron temperature 0 and 10C. And column 250 and 300 kasi 270 ka, di ba? So, lagay mo yung mga properties. So, at 270C, kilopascals, and interpolate mo muna to. This is a double interpolation. So, yan lalabas mo, enthalpy, entropy, and specific volume. Bakit? Kailangan natin specific volume para sa mass flow rate. Yan. May tayong volumetric efficiency sa volume, di ba? Kailangan natin yan. Then, at 9.95 C, dito 0.10, so meron ka ng 270. So, interpolate mo naman siya. So, S1 is 194.040 kJ per kilogram. Ito kasi ang value sa table is 3 decimal places. So, tatlo. So, tatlo ka rin dito. S1 is 0.7255. B1 is 0.067653. Anim yan na, anim. Yan, cubic meter per kilogram. Pag maglaran off. At P2, 1,000 kilopascal. S2 is equal to S1 or 0.7255. So, ang available mo is 1670 and 1,000 and 1,200. So, at 1,009, so interpolate mo to. Ito, ang enthalpy entropy mo. Huwag ka na gumawa ng volume. So, at 0.7255 kilo per kilogram, alin interpolate mo ito? Ito, entropy. So, at this entropy, interpolate mo, S2 is equal to 218.012. Huwag mo na kunin yung temperature. At 3, 1,009 kilopascal. So, this becomes 3. Temperature is in between ito, 960.7 and 108.43, 40 and 45. So T Saturn is 41.95 C. So T3 subcooled, T sat minus SC is 41.95 minus 10 is 31.95 C. Then using the temperature, 30 C and 35 C, yung H sub F niya, saturated liquid, 64.539 and 69.494, interpolate. S3 is equal to 66.471 kJ per kilogram. So H4 is equal to S3. Same. So kompleto na yung enthalpy mo. Solve for mass. QA is equal to 54 kilowatt. So mass is equal to QA over H1 minus H4 is equal to 54 over 194.040 minus 66.471 is 0.42 TT kilogram per second. So A, yung cooling water required. So QR is equal to M times S2 minus H3, di ba? Visualization ito, tandaan nyo yun. 1, 2, 3, 4, 2 to 3 sa condenser. Or M sub W times CW times delta T. So MW is equal to quantity of cooling water. CW is 4.187 kg per kilogram. Given is delta T lang. Walang entering water, temperature sa kalibig. So delta T lang. So pwede mo gamitin ito. Assume. MC delta T. So this 0.4233 times 218.012 minus 66.471 is equal to M sub W times 4.187 times 11. So M sub W is 1.390 kilogram per second. So this is now your answer. For ball and stroke, ano yung ball? Diameter. And stroke is the length. So B sub D is equal to pi over 4 times D squared times N times N. N is the number of speed. N times the number of cylinder. Dalawa ba itong cylinder natin? Okay, dalawa kasi twin. Eh, walang na 2. Nakalagay twins kaya dalawa ang natin. Times 2. So B sub 1 is equal to M times B sub 1, specific volume at 1. Diba? 0.4233 times 0.067653 is 0.028638 cubic meter per second. Natandaan nyo yung specific volumetric efficiency formula. B sub D is equal to B1 over the specific volumetric efficiency is equal to 0.08268 over 0.84 is 0.03490 cubic meter per second. But the length is 1.25 D. So displacement is pi over 4 times D squared times 1.25 D times 27 revolution per second times 2 is equal to 0.034093. So the diameter is 0.0863 cube root or 8.63 centimeter. And length is 1.25 times 8.63 is 10.79 centimeter. Wait lang. So C is equal to M times h sub 2 minus h sub 1 is equal to 0.4233 times 218.012 minus 194.04. So W is equal to 10.15 kilowatt. Ito yung power input mo. So this is the answer. And this is now, ang sagot mo dito is dalawa. Pag sinagot mo, hindi nakalimutan mo lagyan ng L. So mali ka, di ba? Hindi pwede consider isa lang. Itong ano, isa lang ang sagot mo, diameter lang, mas wala kang length. Tapos ito tama to, 1 na point. So hindi na yung pwede. Okay? Number 5. An ideal vapor compression refrigeration uses a subcooling superheated heat exchangers. Ito na yan. Meron tayong heat exchanger na. With 10 C of superheat added. The evaporator operates at 30 C. The condenser at 1.4 megapascal. There is a cooling requirement of 50 tons. If the fluid is R12, determine A, the mass flow rate, B, the COP, C, the refrigerating effect, and D, the degrees of the cooling and the power required. So given superheat is 10C, we have a negative 13. So negative 13 ito may minus dito. QA is repitance R12. Ayan, R12. Required A, mass flow rate, B, the COP, C, the refrigerating effect, D, the degree of subcooling, E, the power required. Solution, so this is now the PS diagram. Better na ilagay nyo pa yung flow diagram. Makita nyo yung heat exchanger doon. R12 is table 11 and 12 ng Stoker. At state 6, negative 30 evaporative temperature, Tsat is 100.4 kilopascal. Diba? So H6 is 174.076 kilojoule per kilogram. H6 is ito, saturation properties. At state 1, so T1 is equal to negative 30 plus 10. So madadagdagan ng 10. It's negative 20C. And P1 is 100.4. So at 100 kilopascal, approximately, kasi para din naman yung 0.4. Ang layo na nag-agwat ng 200 na yata. So negative 200C. S1 is 179.861 kilojoule per kilogram. So you can interpolate that. S1 is equal to 0.7401 kilojoule per kilogram. So to state 2, P2 is 1.4 megapascal or 1.4 kilopascal. So S2 is equal to S1. Ito, asymptotic siya, 1 to 2. Then, sa table, ito yun. In temperature 80 and 90. So, wala kang makita dyan. H is equal to 227.891 and 235.76. Ito yung basehan. Bakit ito ginagamit? S is 0.7355 and 0.7575 in between niya. 0.7401. So, interpolate, H2 lang kukunin mo is 229.538. And at 3, 1.1 megapascal or 1,400 kilopascal condensing pressure. So, sa table, ito yon 1366.3, saka 152.5.9. Ito yung enthalpy, saturated liquid. So, saturation temperature, kailangan mo yon kasi nag-ano ka, di ba, subcool. So, H sub 3 is equal to H sub F. is equal to 91.355 kilojoule per kilogram. Saturation is 56.06. At state 4, so S3 minus S4 is equal to S1 minus S6 kasi sa heat exchanger. Diba? Yung change of enthalpy nito saka change of enthalpy niya equal kasi yung flow is equal din. So yan. So makuha mo yung S4. So 91.355 minus S4 is 179.861 minus 174.076. So S4 is 85.5706 kilojoule per kilogram. Also, S5 is equal to S4 is 85.57 kilojoule per kilogram. And now, solve na. Kompleto na tayo ng enthalpy. So the mass flow rate is QA is equal to M times H6 minus H5. Ulit natin. Yan. 6 and 5 or 1 minus H3. So 50 times 3.516 is equal to M times 174.076 minus 85.57. So the mass flow rate is 1.9863. Now B, COP. COP is equal to QA over W is equal to H6 minus H5 over H2 minus H1 or 174.076 minus 85.57 divided by 229.538 minus 179.861. COP is 1.72. Now, refrigerating effect is QA is equal to H6 minus H5 or 174.076 minus 85.57 or QA is equal to 88.506 kilojoule per kilogram. Letter D, the degree of subcooling degrees. At 1.00 kilopascal, the condensing pressure, saturation is 56.06 C. So at H4, 85.57 kilojoule per kilogram, ano yung temperature naman? So sa table, makita mo saturation niya is in between siya ng 84.868 and 90.201 ng 85.57. Saturation is 50 and 55. So T4, by interpolation is 50.66. Subcooling is 56.06 minus 50.66 is 5.4 C. Centigrade. Ito yung answer mo. Subcooling. A, the power required. W is equal to M times H2 minus H1 or 1.983 times 229.538 minus 179.861. So W is equal to 98.67 kilowatt. So this is now the answer for the power required. Sample number 6. A vapor compression heat pump uses R12 and provides 34,000 BTU per hour of heating. The evaporator pressure is 30 psi absolute and the refrigerant enters the compressor at 20 Fahrenheit. So English units. The compressor's isentropic efficiency is 80% and the condenser pressure is 125 psi. The electricity to drive the compressor comes from a power plant with an efficiency of 40%. Determine A, the compressor power, B, the ratio of heat used in the power plant to produce the electricity to the heat output of the heat pump. Given R12 QR is 34,000 BTU per hour. As the PSA evaporator pressure, 25 and compressor entering temperature. Required A, the compressor power. B, the ratio of heat used in the power plant to produce electricity to the heat output of the heat pump. Solution, so ito yung figure mo. Dahil binanggit dito, actual. So meron siyang actual, meron siyang asymptotic. Diba sabi ko, is it asymptotic o hindi? So may given siya dito. So ang actual niya is hindi asymptotic. Pero meron kang basis. Nagbinigay efficiency based sa asymptotic. 30 PSI, and 20 pumasok dito. So, okay lang yan. Pwede mong straight yan. Pwede hindi kasi wala nang binanggit ng pressure top. So, R12, table 8, 20, and 21. So, pwede dito. At state 1, 30 PSI and 20 Fahrenheit. H1 is 79.765 BTU per pound. Isakto doon na, isakto. Hindi na walang interpolation. S1 is 0.17065 BTU per pound R. So at state 2, 125 PSIA, S2 is equal to S1 is 0.17065 BTU per pound natin. So properties yun ang refrigerant na. Hindi ko sure kung English yun. So Stoker to kasi yung Stoker SI yun. Sige. Check nyo doon sa ibang table. Ibang book. So at 2, 125 PSIA condenser, S2 is equal to S1 is 0.17065 BTU per pound per hour. So ang value mo, mag-interpolate ka dito sa under 125 condensing pressure is ang S mo malapit is 0.16455 and 0.17087. Ang enthalpy niya is 87.407 and 91.008. So interpolate. S2 is 90.880 BTU per pound again. So at state 2 prime, ito, prime to, diba? Nakman, ano mabasahan mo? Compressor efficiency is H2 minus S1 over S2 prime minus S1. Sa drawing pala makita mo. So mas maliit yung H2 divided by actual. Ideal over actual is the compressor efficiency. Sa turbine, alam mo na yan. Actual over ideal. So 0.8 is 90.88 K minus 79.765 over S2 prime minus 79.765 or S2 prime is 93.66 P BTU per pound. Then state 3, 125 condensing pressure. So S3 is equal to S sub F is 37.283 BTU per pound. At state 4, S4 is equal to S3. So solve for the mass. Kasi ang equal natin dito is compressor power. So wala, given is ito. Heating. Heating is 2 to 3. So dito, cooling. Nag-provide siya kay heating. So sabi, itatransfer yung heat. So it's 2 prime to 3. Condenser sa heating doon. So M is QR over S2 prime minus S3. So 34,000 over 93.663 minus 37.23 or 603.051 pounds per hour. Now solve for the compressor power, which is equal to W times M times S2 prime minus S1 is equal to 603.051 times 93.663 minus 79.765 or 8,381 BTU per hour. So convert to horsepower kasi compressor rated in power or sa SI units it is in kilowatt. English units normally it is in horsepower. Divide mo ng 2544 magiging 3.59 horsepower. Note 2544 is BTU per horsepower hour. Next B, the ratio of heat used in the power plant to produce the electricity to the heat output of the heat pump. So the heat used in the power plant is W over N sub T is 8,381 divided by 0.4 is 20,953 BTU per pound. So ratio is 20,953 over 34,000 is 0.6163. This is now your answer. Sample number 7. So an actual vapor compressed refrigerator has a compressor with inlet conditions of negative 20 C and 130 kilopascal and exit conditions of 60 C and 900 kilopascal. Compressor, so compressor ang given dito. The refrigerant is at 12. The liquid refrigerant enters the expansion valve at 850 kilopascal and exit at 160 kilopascal. Determine the COP.